Hello everyone and welcome to another scientific video with thaprous Productions, and today in this video we are going to discuss about the time duration for the formation of the universe or the age of the universe. How to calculate the age of the universe, that's what we are going to check today. Okay, we know that the age of the universe is 13.8 billion years. Today we know that the age of the universe is 13.8 billion years. But how do we know this? How to calculate this? In this video today, we are going to discuss and stay on. First of all, to calculate this one, we are using the Hubble's law. The Hubble's law discovered by Edwin Hubble, the famous astronomist Edwin Hubble. The famous astronomist Edwin Hubble, he discovered the Hubble's law, and that's what we are going to use to calculate this one. Okay, first the story. Actually, the Hubble, he didn't have he didn't have an observatory, but the sophisticated, a well-equipped and a sophisticated, a nice, beautiful, and brand new observatory was constructed by another astronomist called George L. Rahel on top of Mount Wilson, USA. So while staying in that George L. Rahel's Mount, the observatory which were located on top of Mount Wilson, Edwin Hubble kept on his studies, and using that huge reflector type telescope, he checked many corners of the world, many corners of the universe using that telescope, and he understood and he saw one magical thing. What is that? He saw most distant stars from the earth are always appearing to be reddish, and most closest stars to the earth are most of the time appearing to be yellowish. So the most closest stars are appearing yellowish, and as the stars go away and away and away and away, further and further, they are appearing to be more reddish. He thought, why is it happening so? And he understood this is an effect of the Doppler's effect. The Doppler's effect. What does Doppler's effect says? Doppler's effect says that if there's a star or if there's any source and if there's an observer, and when the source is giving out a certain wave, it can be a sound wave, it can be a light wave, no problem, whatever, the wave, a wave. If the source is not moving, we can observe the exact frequency F1. We can observe the exact frequency of F1. But if the source is moving away, see, if the source is moving away, what will happen? The wavelength of the wave will be stretched. The wavelength of the wave will be stretched. So that what will happen? The observable frequency will be less. Why? In a certain medium, the wave has a certain speed. If the wavelength is not changing, then it's okay. But if the wavelength is getting stretched, the observable frequency is getting lesser. So finally, the observable frequency is given by this formula. See, F2, the observable frequency, is equal to V divided by V plus U multiplied by the real frequency of F1. V divided by U plus V, V divided by V plus U multiplied by the original frequency of F1. So V is the speed at which the wave is approaching the observer, and U is the speed at which the source is moving away. So what will happen? When the source is moving away, the wavelength will be stretched, and the observable frequency, the observable wave will not be like this, it will be like this. So the frequency will be lesser. The observable frequency will be lesser. So that he understood this one, and he understood that the wavelength of red color is lesser, the wavelength of yellow color is higher, so that because of this movement which is happening away from us, the wavelength is being reduced. So then he thought, why is it happening so? And he understood that the entire universe is expanding in a certain rate. So as the universal expansion is continuously happening, those all stars are moving away from us every minute, every moment. And he collected data and he plotted the graph against the distance of the star and the red shifting. Distance of the star and the red shifting. And he saw a pattern like this. a pattern like this. And he saw this graph is type of is having a type of y equals mx. Y equals mx plus type graph. One y equals mx type graph. Sorry. Then he understood that if the graph is y equals mx type, then v, the velocity at which the stars are moving away from us, is equal to mx type, means a constant multiplied by the distance. V equals hd. V is the velocity at which the stars are moving away from us, and h is the Hubble's constant, and d is the distance from us to the star. So as the distance goes away and away and away, the moving speed is also become higher and higher and higher. See, according to the graph. That's what he understood. Y equals mx type graph. Okay, now using the Hubble's law, we can calculate the time duration for the formation of the universe, or the age of the universe. We can do it like this. V equals hd. V, the velocity at which the stars are moving away from us, is equal to dt divided by dd divided by dt. D means the distance from us to the star, and t is the unit time duration that in which we are calculating the speed. So dd divided by dt is equal to hd. Right? Okay. Now we can do like this. We can take this thing to here and this thing to here, so that dd divided by hd is equal to dt. Now what can be done? Now dt can be taken to this side, and these things can be taken to this side, and 1 by h can be kept as a constant. So dt will be equal to 1 divided by h multiplied by dd divided by t. Now we have to integrate this equation. Integrate both sides. What will happen? dd, after integrating, it will give us t equals 1 divided by h is 1 divided by h, dd divided by d integration gives us log d. So finally the equation is t equals 1 divided by h multiplied by log d. Now what is Hubble's constant? Here's the value of the Hubble's constant. Finally, Hubble understood the value of the Hubble's constant is 2.3 multiplied by 10 to the power minus 18 seconds. So he calculated this value according to this graph. Using this graph, he calculated this one, because redshifting is directly proportional to the speed at which the source is traveling away from us. Not direct proportional, but using the redshifting, we can calculate the speed at which the source is traveling away from us. So using that one, he calculated this one. Now we can use this value in here. So finally, we can do like this. We can substitute like this. T is equal to 1 divided by h means 1 divided by 2.3 multiplied by 10 to the power minus 18 and log d. Now what will happen? Log 100 is equal to 2. Log 1 million is equal to 6. Log 1 billion is equal to 9. So compared to 1 divided by h value, log d value is very small. Very small. See, log d value is very small compared to 1 divided by h value. So that for a certain moment, we can forget about this log d value. We can forget about that value. And finally, we can take this calculation. T equals 1 divided by 2.3 multiplied by 10 to the power minus 18 seconds. And finally, the value will come as the age of the universe after calculating this part. After calculating this part, the T, or the age of the universe, will come as 13.8 multiplied by 10 to the power 9 years. It means 13.8 billion years. And this is how to calculate the time duration for the formation of the universe, or the age of the universe. Thank you for watching, and let's meet again with a valuable video, a scientific video like this. And see you soon. Thank you.